Hi, everyone. Thanks for being here, either in person or watching online. My name is Vieira. You can call me Gui. I'm a software developer at Shopify, working at the API Partners team. And I live in Vancouver, Canada. I'll make some assumptions that may or may not be related to you. Maybe GraphQL is something new to you, and you want to learn more about it. And I'll break some GraphQL queries down, especially at the first half of the presentation, so hopefully everyone can enjoy the presentation. Maybe you want to use GraphQL in a project. You can even see how GraphQL would look like there, but you haven't implemented it yet. Or you already maintain a GraphQL project, but you want to extend it. I've been in all of these positions, and there's something common to all of them. It's a question, and this question can come from yourself, a teammate, a manager, or from the internet. GraphQL versus REST. We've been there reading and discussing how GraphQL compares with REST multiple times. Is this a fair comparison? Are we comparing apples to apples? Is GraphQL just a replacement for REST? So let's explore what GraphQL can do beyond HTTP APIs, and then we'll revisit this question at the end. So let's build an API here and explore it. I present you Space Trips. This is a fictional API for the space tourism industry. With this API, travel websites can book space flight tickets, manage their passengers, which are the customers, and companies operating space flights can manage the flights, change schedules, and also manage the passengers. Let's explore some queries that we can do here. We can start with this query that will return the scheduled flights, so the upcoming flights. We start with the flight field, and we pass the schedule status. So the schedule status maybe just removes the flights that were canceled or happened in the past. And this field returns a connection. So a connection in GraphQL, it's a convention. It's actually a specification that's very common to GraphQL APIs. And it's a way for us to manage arrays of objects and have features such as pagination, cursors, and other more. And we have the nodes object here. So the node objects basically represents what you are returning. So we are returning an array of flights, and for each flight, we want information such as ID, the company that is operating the flight, the ticket availability, and departure and arrival times. Okay, so we are ready to make our first GraphQL request to our API. So that's the response, and returns two flights. One flight from space Y, and another flight from Blue Beginning. So our space flight company is here. Let's get more information about the space Y flight. We can start by, actually before this, I want to show that the response mirrors the query. So the same way the query starts with flights, the response mirrors this same structure. So we have flights, then nodes, and then the fields for each flight. The structure of a GraphQL response is very predictable, and this is very important because it makes you write very confident code. You don't need to check for all kinds of scenarios. Now we will do another GraphQL query, and we want to return the passengers for the spacewise flight. And for this, we start with the ID. We get the flight ID, and we call the flight field, we pass the ID. And for this flight, we want to query the passengers. And passengers is already, it's also a connection field. And for each passenger, we want to return the name, the email, and the tags. Okay, that's nice, but can we make this query more reusable? Yeah, we can use variables and extract hard-coded values into variables. So instead of changing the entire query, we just change the variables. And we start this by wrapping the query in an operation. The operation name can be anything. It's totally user-provided. And it's a way for clients, API consumers, to organize their queries, give a descriptive name. And then we declare the variable name and the type. So we have flight ID, that's our variable name, and the type is ID. Now we replace our hard-coded value with the variable name, and instead of passing the variable in the query, we pass separately in a JSON object. Now we're ready to run this query. And the response has 2 passengers for this flight. But what's happening behind the scenes here? The GraphQL client gets your query and converts into a JSON payload. So it makes a post request to your GraphQL endpoint. And for the JSON payload, it has a query key with just a string with your query, and the variables key with an object with the variable names and value. So that's what happened, that's what GraphQL clients do with your query. And on the server side, we have a controller here that calls the schema and executes the query. And for the execution, we need to provide the query name, the variables, and also the context. Context here is very important. Context defined by the application. So you can put any information there, and we usually put information that's very useful for executing the query. Here we are passing the current user. So we can use the current user information for authorization purposes. Query and variables are provided by the user, and context is provided by the app. So we have total control over the context. And the result of the execution is serialized to JSON to create a JSON response. Let's replace all values with literals here. And as you can see, query is just a string, variables is just a hash, and the response is also just a hash that we can encode to JSON for the response. So there's nothing here that is related to HTTP. There are no HTTP methods, paths, query strings, headers, nothing here. So GraphQL doesn't depend on HTTP. We can execute in different contexts. And we say that GraphQL is transport layer agnostic. The same way you can execute GraphQL in a controller, you can also execute GraphQL in a background job, or even execute GraphQL queries that are stored in the database. So this opens a lot of possibilities for GraphQL. Because GraphQL has a schema, we have the context that we have total control for authorization, for anything that we need. The responses are very predictable. GraphQL needs very simple data structures to run, and the response is very predictable. So there's a lot of potential here for usage besides executing a controller. Webhooks. We have a new company here. This is Orbital, also a fictional company, and they are a website that sells spaceflight tickets. Orbital uses the Space Trips API to book those tickets and to manage their customers. And they want to improve the way they manage their customers, which are the passengers. When a flight ends, they want to add the astronaut tag to each passenger they've booked for this flight. So there's an event here that triggers this flow. And for this, they need to subscribe to a webhook. So this is a GraphQL mutation, and that subscribes to the webhook, and it subscribes to the flight finished topic. So every time a flight finishes, it will trigger a webhook. And Orbital needs to set up a web server to receive those webhooks. So they set up a web server, they expose an endpoint, and they also need to maintain this web server to make sure they don't miss any webhook. A flight ends, and they receive their first webhook. And the first webhook has a lot of information about the flight, but no information about the passengers. And they need the passenger information to add the tags to them. So without the passenger data, they can't add the tags. Well, they need to make an API request to get the data they actually need. So then, let me go back here. So they get the flight ID, and they create a new query. They pass the flight ID here, and they query for the passengers' IDs. Now the response has the data they actually need here. And now they finally can add the astronaut tags to those passengers. So it's a lot of work, and they get a webhook that doesn't have the information they actually need. And that's the whole workflow. They receive a webhook, they make an API request just to get the passenger IDs, and then they add the tags that they need. Can we improve this? Is it possible to let API clients choose the webhook payload? Yeah, we can do this with GraphQL, because with GraphQL, we define queries. On this webhook subscription, they are creating a GraphQL webhook, and they pass a GraphQL query with the information they need. The client provides the query, and the server provides the variable. So we have the flight ID variable here, and this variable will be provided by the server for the flight that just ended. So they subscribe to the webhook, and on the server side, we have a background job that used to just serialize a simple webhook. But now our background job executes GraphQL. It gets the information from the webhook subscription and runs GraphQL in this background job. And at the end, it sends the result of the query back to Orbital. Okay, so now we have the new webhook, and the webhook only has the information that Orbital needs, nothing more, nothing less. And this whole flow here that needed an extra request, now don't need the extra request anymore. They have all the information they need on the webhook payload, and they can just add the astronaut tags to the passengers. And this is very good because instead of having a one-size-fits-all approach, when you let clients, API clients, to define the information they need, this adds a lot of value to them, make their lives easier, very easy to maintain, and also it's more efficient. We are not making unnecessary API requests here. Let's do something different now. We have this flow, and it's working fine, but Orbital needs to maintain our web server just to receive the webhook. They need to make security updates, they need to monitor, they need to deal with networking issues, they need to handle missing webhooks if they have any kind of outage. But is it possible to to move all this logic that receives the webhook and makes an API request to the server? Can the server execute code that was provided by the client? Yeah, we can do this with WebAssembly. So WebAssembly allows us to write code in different languages, compile this code into a package that can run in a very safe environment. And with this flow, we don't need all this network coming from and to our server. And Orbital won't need to maintain a web server anymore. In the same way, it's just a very simple logic going on the Orbital, so it's very easy to write some code for this. Several languages compile to WebAssembly, and because WebAssembly support is coming soon to Ruby, we can use Ruby for this. And we write a simple method here called perform, and the argument that this method receives is the webhook that we just defined. So we just defined the webhook, so we know what's the argument here is very predictable because that's the GraphQL response. That's our argument for our function, and the function, the method extracts the passenger IDs here, and then runs the add tag mutation, passing the passenger IDs variables there. Now Orbital compiles this code to WebAssembly, uploads to space scripts, and gets an ID for this script. And now, for this new webhook, instead of passing a URL argument, Orbital passes a script ID. So instead of delivering to an HTTP endpoint, it executes the script. On the server side, that's how the background job for webhooks looks like now. It still executes the query that they have subscribed to, and it loads the WebAssembly script, and it provides some context. So this context is very important to create a safe environment to run this script. And what it's doing is, for whatever GraphQL query is made here, it adds the current user context that we need for authorization. So the execution here will be very similar to the execution we had, for example, in the controllers. And then it executes the script in this context. Now the whole flow is within the space strips servers. We don't need the back and forth from network requests. We don't need to handle missing webhooks. and Orbital doesn't need to maintain this web server just to receive webhooks, do some logic, and create a mutation. Another nice use case here, book operations. Orbital now has a new requirement. They need to export all their passenger data to synchronize with some external systems. And they have 5,000 passengers, 5,000 customers, and this number grows every day. And this is a very common use case. A lot of API clients use APIs to synchronize data. They often iterate over pages and pages of records. They do this a lot. They do this for marketing. They do this for accounting, data analytics, you name it. But on the other hand, servers need to protect the stability there. They need to ensure response time, and for this, usually they create pagination limits and also rate limiting. And in a regular use case, they make a query with a cursor, and whenever the hasNext page returns true, it means they need to keep iterating until it reaches the end. This is very inefficient because Orbital has 5,000 customers and the pagination limit is 50. So they need to make 100 requests to get all the passenger data. And this number will only grow. This is very inefficient, not only for the client, but also for the server. And if they want to export data, for example, the flights for each passenger, now they have nested connections. They have nested paginations. This gets unsustainable very quickly. So is there a way to export large amounts of data while keeping the server stable with a good response without overwhelming the server, and also doing this in a very efficient way? For this, we can use webhooks. For this, we can use book operations. So book operations are queries that run as background jobs. Instead of running the query once, we can split this query into smaller jobs and run them in parallel whenever possible. And the way it works is the pagination will be handled by the server. So Orbital here is just removed all information about pagination, so we don't see first 50 on the query anymore. And then they create a mutation to run this query as a book operation, and they pass the query that they want to run. And now this query will be run as a background job on the server. And the server parses the query, detects the connection, and splits this job into smaller and smaller jobs that eventually will be assembled together and be available to the user. And because this runs as background jobs, they can run in parallel. You have a lot of control of the pace they run. They don't affect the overall API performance. And when the book operation is finished, the client, in this case Orbital, can download the query result as a JSON file. So this removes a lot of complexity for exporting large amounts of data from the client, makes it more efficient also on the server side, and it's a very good feature for everyone to adopt. We have book operations at Shopify. If you want to try, you can go to the admin API documentation and experiment with book operations. All right, so we explored some use cases of GraphQL beyond HTTP APIs. We explored webhooks, WebAssembly, and book operations, but there are many more use cases for this. We can use for WebSockets, event messaging, you name it. So back to our original question, GraphQL versus REST. GraphQL is not just a replacement for REST. There are a lot of possibilities for GraphQL. So when you're comparing GraphQL to REST, you're comparing REST to the tip of the GraphQL iceberg. And there's a lot to explore there. So I invite you to explore GraphQL a lot. There's a lot to discover then. And thank you.